Okay, so this question is similar to the one which we have solved before. If the product of the digits of a two-digit number x is 6, what is the value of x? So again, this is a value question. Two-digit number x is 6. So I can say x can be 61, x can be 16, x can be 32, x can be 23. So out of these four values, we need to identify any one value. So let's check what has been given. The first statement says x has only one unique prime factor. Now if I check all the four values, we have 32 with us, which has 2 as one of the unique prime factors. Also we have 16 with us, which again has 2 as one of its prime factors. So clearly statement 1 is not sufficient. Now let us move on to statement 2. Statement 2 says that under root of x is integer. Now if I see all the four numbers, we have 16 with us. Under root of 16 is 4, which is an integer. So we can say that statement 2 alone is sufficient to answer the question. Answer choice B. Okay, so this is a pretty easy question. If the product of the digits of a two-digit number is 12, what is the value of x? So the product of the two digits is 12 and we need to find out the value. So this is basically a value question. Okay, so what we are given is x is 12. X is a two-digit number and the product is 12. So x can be 43, x can be 34, x can be 62, x can be 26. You can see 4 3s are 12, 6 2s are 12 and vice versa. So let me go down to the two statements. The first one says the units digit of x is a prime number. So here you can see 2 is a prime number, 3 is a prime number. So we have two numbers, 43 and 62. So statement 1 in itself is not sufficient. So I will remove out answer choice A and D. Now let's solve the second statement. It says x is even. X is even, so what I get is x can be 34, 62 or 26. So basically we have three values for x, 34, 62 and 26. So again 2 is not sufficient. Now let us try both. So 1 and 2, it gives statement number 1 we have 43 and 62, and statement number 2 says that x is even, so I get 62. So both the statements together are sufficient to solve the answer. So answer choice C. Okay, so this one is quite tricky. What we are given is x and y are positive integers and x plus y the whole square is an odd integer. Is x an even integer? So what we are given is x plus y the whole square is odd. And when I say odd number, I will say it is 9. So 3 square is 9, so I can see that x plus y is equal to 3, or x plus y is equal to odd. And I can substitute another number as well. If I say this odd number is 81, then I can say 9 square is 81. Again, 9 is odd. So from the given information, we can see that either x is even, y is odd, or x is odd and y is even. So in both these scenarios, I will get the answer to be odd. Let us move on to the answer choices. The first statement says x raised to 4 minus y cube is an odd integer. Now here, if I say 4 minus 3 is equal to 1, which is nothing but odd. Now here I have taken 4 as even, this is odd. Now I will try the reverse thing. Say 3 minus 2, here 3 is odd, 2 is even. So again I get 1, which is odd. So if x is even, then the answer is odd. If x is odd, then also the answer is odd. So clearly 1 is not sufficient. Now let's move on to answer choice. The second statement, which says 0 is less than y cube minus y is less than 24. Now firstly, if I take y to be 3, say y is 3, so we get this will become 27 minus 3, 24. Here 24 cannot be less than 24, so we cannot consider this. Now let's take y is equal to 1, another odd number. So what we get is 0 is less than 1 cube minus 1 is 0, 1 minus 1 is 24. Again 0 cannot be less than 0, so I cancel out this. Now let's try y with even number. So 0 is less than 2 cube is 8, 8 minus 2 is 6 is less than 24. So here this equation is quite good. I can consider this, and here I can clearly say that y is even. So statement 2 is sufficient. Remember, the question had asked whether x is even or not. Now here I can say that y is even, so x will automatically be odd. So I will write here x is odd. So answer choice B.